Hi, this is Halal. In this video on Mathematical Economics series, we will try to solve a problem on price discrimination in case of a monopolist. The question is like this. A discriminating monopolist is able to separate its customers into two markets with respect to demand functions as x1 is equal to 16 minus 0.2 p1. Okay, this is the market demand function in the first market, and in second market we have x2 is equal to 9 minus 0.05 p2. Okay, where p2 is the price in the second market and x2 is the uh, quantity in the second market. Total cost function of the monopolist is given as that is c is equal to 20 plus 20x, where x is equal to x1 plus x2. Okay, so this x is actually x1 plus x2. We have to find the profit maximizing values of x1 and x2. That is, we have to find the profit maximizing values of output in both markets. Also we have to find the prices charged in each market and maximum profits. Okay, after that we have to find the absolute elasticities of demand in the two markets. Okay, so let us see how to find. First, what we are being given the demand function in the first market, demand function in the second market. Let's take the first market. Okay, so we take the first market. What is the demand function? That is x1 is equal to 16 minus 0.2 p1. Okay, this is the demand function in the first market. Now first we form the inverse demand function. That is, we will solve this very relation in terms of p1. Okay, or I can write simply transposing this term on LHS. This PQ will become positive 0.2 p1 is equal to 16 minus x1. Okay, or 0.2 can be written as 2 over 10 p1 is equal to 16 minus x1. Okay, or p1, when solving this we will get p1 is equal to, I am not showing the steps here because of the lack of the space. Okay, this will come out to be 80 minus 5 x1. Okay, this is our inverse demand function. Now to find the profit maximizing values of x1 and x2, what we have to find, we have to find the condition that our marginal revenue should be equal to marginal cost. So first we need to find the total revenue. Now total revenue in first market would be equal to price in the first market into quantity produced in the first market. Okay, so p1 is this 80 minus 5x1, and to this we multiply this quantity, that is x1, and it comes out to be 80 x1 minus 5 x1 into x1 is x1 square. So this is our total revenue in the first market. We need to find the marginal revenue. So marginal revenue in the first market is equal to, now what is marginal revenue? It is simply the derivative of total revenue. So I will write derivative of total revenue in the first market, our t x1, that is quantity in the first market. So differentiating this total revenue function with respect to x1, we are left with derivative of x1 is 1, so we are left here 80 minus derivative of x1 square is 2x, so this 2 becomes coefficient, 5 2s are 10, we are left with 10 x1, and 2 minus 1 is 1, so x1 raised power 1 is equal to x1. Okay, so this is our marginal revenue in the first market. Now what is our cost function? Let us see. Cost function is 20 plus 20x. So I will write here c is equal to, that is 20 plus 20. In place of x we have x1 plus x2. So I will write here 20 x1 plus 20 x2. I hope you understand what I am telling, because if x is equal to x1 plus x2, so this becomes 20 x1 plus 20 x2. Okay, so what is the cost in the first market? So marginal cost in the first market would be equal to the derivative of cost function in the first market upon dx1. That means we have to partially differentiate this very cost function with respect to x1. So we will use here partial derivative. Let us use the proper symbol, that is the proper symbol for proper derivative, because we have two variables here, x1 and x2, and we are being told to partially differentiate this. Now the derivative of a constant is 0. derivative of x1 is 1, so we are left with 20. Okay, now what is the derivative of x2? Because we are differentiating with respect to x1, so derivative of x2 can be assumed as constant, and the derivative of a constant is 0. So this term becomes 0, first term becomes 0, and we are left with middle term. The derivative of x1 is 20. Okay, now using our equilibrium condition, so let me write for profit maximization, we need our marginal revenue 1 should be equal to marginal cost 1. That is, marginal revenue should be equal to marginal cost. This is the profit maximizing condition. So what is our marginal revenue? That is 80 minus 10 x1 should be equal to 20. When solving, this will come out to be, if we I can write it to 10 x1 is equal to, now 80 minus 20 comes out to be 60, or x1, let me write here, x1 is equal to 60 divided by 10, so this comes out to be 6. Okay, so profit maximizing value of x1 would be 6. That is, profit maximizing level of x1 in the first market would be 6. Okay, now we have to find the x2. That means we have to go to the second market. Now first I will try to um, uh, what I can say, I will try to use the first demand function to derive also the absolute elasticity. Okay, now what is the formula for elasticity? So I will write here, elasticity of demand is equal to dx1 upon dp1 into p1 over x1. Okay, before that I have to find the profit. Let me rub this out to make things more simpler. So I will also see what is the price charged in the first market. So just put x1 is equal to 6 in this equation in inverse demand. Let us say this is equation first. In equation first, to get our optimal price, so we have p1 is equal to 80 minus 5. The value of x1 is 6, so this is 80 minus 5, 6 are 30, or the price charged would be equal to 80 minus 30 is equal to 50. Okay, we got the value of p1 also. Now we can, so the price charged in the first market would be 50. Okay, now we can find the absolute elasticity of demand in the first market. So elasticity of demand, price elasticity of demand is dx1 upon dp1. That is change in the quantity or change in the price in the first market times p1 into x1, that is equilibrium price and quantity. Now what is our actually it is minus here. So dx1 upon dp1 simply means we have to take the derivative of our this demand function with respect to p1. Okay, so this will cut, the derivative of 16 will be 0, derivative of p1 is 1, so we are left with minus 0.2. Okay, what is our p1? P1 we have calculated, it comes out to be 50. Our what is our quantity? That is 6, or we can write it like this, 2 over 10 into 50 over 6. So we have this gets cancelled, 2 ones are 2 threes are, so we are left with 5 over 3. Okay, so what is 5 over 3? 5 over 3 will come out to be, so we have 5, we have 3, 3 ones are 3, we are left with 2, so we have here point, so we have 3, 6 is 18, then we are left with 3, 6 are 18 again, so we will get price elasticity of demand is equal to 1.67, negative 1.67, or absolute elasticity of demand that is, if we take the absolute value, we are left with 1.67 would be the price elasticity of demand in the first market. So I will write 1.67. okay. So what does this number tell us? It simply tells us if price increases by 1%, quantity demanded will decrease by 1.67%. okay. I hope I am making myself clear. So let's go to the next market. Using the same method, we can find the value of x1, p1, and the elasticity of demand in second market. okay. So let us use another color. So what is the demand function in second market? That is x2 is equal to 9 minus 0.05 p2. okay. First step is to solve it for p2, or we can write 0.05 p2 is equal to 9 minus x2, or this can be written as 5 over 100. P2 is equal to 9 minus x2. When solving this will come out to be P2 would be equal to 180 minus 20 x2. okay. If you transpose, you will get this very thing. So we got the inverse demand function. Now we have to find the total revenue in the second market would be equal to price in the second market into quantity of the second market. So what is our price? Price function is 180 minus 20 x2, and to this we multiply x2, because price into quantity gives us total revenue. So this will come out to be 180 x2 minus 20 x2 square. okay. This is our total revenue in the second market. Now what is marginal revenue? Marginal revenue in the second market is simply the derivative of total revenue in the second market over dx2. That means we have to differentiate this very revenue function with respect to x2. The derivative of x2 is 1, so we are left with 180 minus the derivative of x2 square is 2x, so 2 becomes coefficient and it is multiplied with 20, so 20 into 2 is 40 x2. This is our marginal revenue. What is our marginal cost in the second market? That is simply the derivative of total cost function with respect to x2 this time. okay. What was our cost function? This was our total cost function. Now we have to differentiate with respect to x2 partially. Derivative of constant is 0. Now the derivative of x1 would be here 0, because x1 is assumed to be constant, and we are partially differentiating with respect to x2, and this variable becomes constant. So this is 0, this also becomes 0 if it is assumed to be constant. Now what is the derivative of x2? It is 1, so we are left with 20 again. okay. So the marginal cost is 20. What is profit maximizing? Profit maximizing condition is our marginal revenue in the second market should be equal to marginal cost in the second market. What is our marginal revenue? That is 180 minus 40 x2 should be equal to 20. okay. Now let us try to solve this out. Now if we write 40 x2 is equal to, now 180 minus 20 comes out to be 160, or x2 comes out to be 4 4s are 60. So our value of x2, level of output in the second market, would be 4. I will write here. okay. Now we have to find price. okay. Now put x2 is equal to 4 in this equation in inverse demand function. Let us say this is second equation. In second equation, so our p2 will become, our p2 is equal to 9 minus sorry, we have 180 180 minus 20. What is x2 which we got here? 40. Oh, sorry, 4. When we try to solve this out, what will it come? This is p2 is equal to 180. Now 20 into 4 is 80, so p2 is equal to 180 minus 80 is equal to 100. So the price in the second market would be equal to 100. So I will write here so price charged would be 100. okay. Now we have to find the absolute price elasticity of demand in the second market. So absolute price elasticity of demand in the second market is simply dx2 upon dp2 into p to our x2. Okay, so this is, we have to find this very coefficient. Now dx2 upon dp2, that means we have to differentiate this very demand function with respect to price. So derivative of 9 is 0, derivative of p2 is 1, so we are left with minus 0.05 into what is our equilibrium price. We have calculated it, it has come out to be 100. Our what is equilibrium quantity, which is 4. Okay, when we solve, this will come out to be minus 5 upon 100 into 100 over 4. 100 and 100 will get cancelled. Now we are left with minus 5 upon 4. What is minus 5 upon 4? So we have 4 ones are 4, we are left with 1. Here is 0.0. 4 twos are 8, we are left with 2. 4 fives are 20, so we got minus 5 over 4 is equal to minus 1.25. that means our absolute price elasticity of demand in the second market is equal to 1.25. okay, so we have calculated absolute price elasticity of demand in the second market, which comes out to be 1.25, and it simply tells us if price increases by 1%, quantity demanded will decrease by 1.25%. okay, so 1.25 I will write here. 1.25 is the absolute price elasticity of demand in the second market. Now what we need to find, we have to find the profit earned by the monopolist in two markets. okay, for that I will rub this out. okay, I shouldn't have rubbed this out. So what is pi? Profit is equal to total revenue minus total cost. okay, now profit would be equal to, what is total revenue? That is total revenue in the first market plus total revenue in the second market minus total cost. I will write total cost because it is same in the two markets. So this is TC. So what was our total revenue in the first market? That is why I shouldn't have rubbed this out. So let us rub this fully. What was our, we have to calculate again it now. okay, so let's try to, we have x1 is equal to 16 minus 0.2 p1, and when solving for p1 what we got, which was equal to 80 minus 5x1, or p1 into x1 was our total revenue in the first market, and it came out to be something like 80x1 minus 5x1 square. okay, this is our total revenue in the first market. So I will write 80x1 minus 5x1 square plus what is the total revenue in the second market. So I did the mistake, I have to rectify this. Now I have to again calculate the total revenue in the second market. So second market was x2 is equal to 9 minus 0.05 p2. When solving for p2 we got p2 was equal to 180 minus 20 x2. So our total revenue in the second market would be equal to p2 x2, which is equal to 180 x2 minus 20 x2 square. So I will write here 180 x2 minus 20 x2 square. okay, now this is our total revenue. What is our total cost minus what is our total cost function was given. Total cost function was this, that is 20 plus 20. In place of x we have x1 plus x2, so I will write x1 plus x2. okay, let me use the long bracket here. Now just give the values to x1 and x2. So what we got, x1 was 6, x2 was 4, so we have 80 into 6 minus 5 into 6 square plus 180 x2. X2 is 4 minus 20, x2 is 4 square minus we have 20 plus 20. Now what is x1 plus x2? That is 6 plus 4, 6 plus 4. I'm not using the proper brackets here. So now 80 into 6 is 480 minus 6 6 are 36, 5 into 36 plus 180 into 4 is 4 zeros are 0, 4 8s are 32, 4 1s are 4, 5 6 7. I hope I am making the calculation right. 4 4s are 16, so we have here 16 minus now 20 plus 6 plus 4 is 10, so I will write here 10. Now let's do the calculation again. So we have 480, this is 5 6 are 30, 5 3s are 15, 16 17 18, so we have 180 plus 720 minus this is 320 minus 20 plus 20 into 10 is 200. Again using the calculation, we have 480 minus 180 plus 720 minus 320 minus 20 plus 200 is equal to 220. I hope so. Now what we have here, so we have these two positive terms, so this is 0 plus 0 is 0, 8 plus 2 is 10, 7 plus 4 is 11, so this is 1200 minus. Now what we are being left here with, so we have 0 0 0 0. Okay, now 2 2 is 4, 2 sorry, we have 0. This is 2 plus 2 is 4, 4 and 8 is 12. Okay, 1 is left out, so 2 plus 1 is 3, plus 3 is 6, and this is 7. So we got 1200 minus 720, and it comes out to be 0 minus 0 is 0, 10 minus 2 is 8, so 11 minus 7 is 4. Okay, so total profit for this monopolist, for this discriminating monopolist, would be equal to 480. Okay, I hope I make myself clear in this video. If you like these videos, please share and subscribe, and also give your valuable comments. That very thing motivates to me make more useful stuff for youth people. Otherwise I have no intention to make videos. Okay, thank you.